I wonder what are we supposed to do, subtract these two numbers?
I got two copies.
Multiplying that by 100.
Oh, so that's the next. So you have to minus 100 from this section, which was 28.
So negative 26 something.
So this one is.
I'm subtracted from which number?
Because that's a positive number.
Good work. I hear lots of good discussion going on.
And you minus off 71, it'll give you negative 28.
0.38.
Right? So if you take 100 from here,
Yeah.
right?
It's gonna be 0.7.
It's gonna be 28 something, that's the negative. Remember, you're looking at positive, so you have to go back and. It's 26. Because I have my negative. It's 28.77.
No. So this is a negative. So you have to take this number,
Let's say you didn't have to take
1 minus this number.
So you take 71.
Yeah, you have to lower the 30.
So you take out 100, minus out 100.
Right, so you subtract.
That's gonna be 7. That's
Subtract.
Oh, no, it's 7.
1 divided this.
Negative.
No, you just need to draw a picture.
Because this is a negative, you have to minus out that negative.
So 0.56.
To get to the other side. I just didn't know, it doesn't matter whichever way you do it.
Yeah.
If you take what I got, if you do calculate, you do credit calculator, like this.
You know what?
If you go 71.23 minus 100.
Actually, it's here. No, it's here.
Because that's the number you paid. That was the zero, right? On your pocket.
I think this number, 0.7.
Yeah.
That's why otherwise you're just 0.7. That's what I'm thinking, that's why there wasn't.
Oh, because this is like.
Are we ready to do this? Want to do this?
So you're doing 71.
That's your number.
All right. So you're in some town with a average driving distance commute of 21 miles, standard deviation of 3.6 miles. Suppose you're, I was thinking of this last night, you're trying to sell some sort of book on tape that lasts 35 minutes for someone to listen to. And you want to know what percentage of drivers you could sell this book on tape to. Right? So you want to know what percentage of drivers have an actual commute between 19 and 26 miles. And you get to assume that standard deviation is normal.
Yep.
Alright, so we need two z-scores. We need one for 19, we need one for 26, and we're going to calculate the area in between those two. What do we get as a z-score for 19?
Negative 0.56.
Negative 0.56. Nice. What do we get as z-score for 26?
1.39.
1.39. Alright, what I like to do is put all these numbers on a bell curve. We've got 19 and 26 as the actual number. Now we have z-scores, negative 0.56 for this one, and 1.39 for this one. And then how about the area below for each of them? Let's start with the easy one, 1.39. So we look on the z-table, 1.39, find the area below, and what do we see?
91.27%.
How much?
91.77.
91.77%.
Yes.
Fantastic. Okay, so this whole thing from here, here, is 91.7. Is that the answer of between 26 and 19?
No.
No, because we need to find this little tail and subtract it off. Now how are we going to find this little tail? Because we got a problem here, this is negative. The answer is not immediately obvious. So let's take a little side note, and let's say, alright, well let's look up positive 0.56. Alright, what do we find the area below that?
That would be 71%, 23.
71.23%?
Correct.
Fantastic, right, that's the area below. What would be this little tail up above right here?
28.77.
28.77.
Right.
Okay, so if we had, instead of positive 0.56, we had negative 0.56, what would be this little area below?
The same thing, but negative.
I agree.
It wouldn't be negative, it would be 28.77%.
Right.
Right.
Alright, so we now know this is 0.2877. We now know the area below 0.56 is 28.77. We're now ready to calculate the area in between these two. And it's just the difference. 91.77 minus 28.77.
62.50.
62.50?
Yeah, 63.
Oh, excuse me then.
63.50%?
Wait.
I believe it was 91.27. I don't know if I've read it wrong. I think I read it wrong, yeah.
Alright, we like that?
No, I think I read one of them wrong.
Good, good, good. Any questions?
It's just 63. Yeah, 63.
63? Yeah, that's right, 63 even, because this is exactly 0.77. That's how weird is that, right? 63% even. Alright, good. What I wanted to do next is just some pure examples of reading the z-table, where there's no word questions we need to think about. There's some questions from your textbook, which just gives us a chance to just plain practice reading the z-table with some of the stuff that's a little tricky. So let
Sorry, I
me
have
pull
a
that up.
question with the last one. The 28 was negative. The 28 was negative?
No,
It wasn't
it
negative.
was 28%. You don't have negative percents. Percents are between 0 and 100%. So it's just 28.77%. Alright, so we're going to turn to page 206 and we're going to start with exercise 7 and then we're going to do 8. I'll pull this up for those of you that
Okay, what page is?
206.
206.
Alright, let's see if I can make this.
But
Did you read that?
for that.
You can kind of read that, right?
Right, but it doesn't show that everybody was 28%.
I'll put the curve down.
But if the way you calculate the 28, you have to go away, that's why.
Alright, so what these two problems give you, these are just z-scores. You don't need to calculate the z-scores, you just need to look on the z-table and find the area in whatever interval they ask for. They can be tricky though. So, alright. So start working on 7 with your team. When you get done with that, work on 8. This will be the last thing we'll do tonight. So just try to think about ingraining what you've learned about the z-table. Right.
We're gonna put that on that one's on the page. That's in the book, right?
It's like 6 different things.
Can you sort of see it?
206.
Alright, if you need to, send a representative from your team up to get a better look. Did that help? That didn't help. I never helped.
So we have a question, right? So when we were looking at this here, this is negative here.
Yep.
So when we have the number, it came out to 2877, we do 100 minus that. It comes out negative here, but we pick it up to negative.
No. So 100 minus 0.77.
So it's 20, so it's never a negative.
Yeah, it's negative now. So you take 100 minus
And it comes
71.
out to 26.
Yeah, so put a minus sign right there.
At or below, yeah.
Yeah. So
So
that
you
kind
always
of,
back down the positive out of
So the right.
yeah, but I wouldn't, that's true, but I wouldn't think about it that way. If the whole thing is 100%, and below it, see that one on the far right, 71.23, that's 71.23. What's left?
Right, no, because when I saw in the book, it says positive there, it doesn't have a negative, of course, but on the side it's negative. That's what it was confusing.
Yeah, so the whole thing is 100, 71.23 is there, so
And then
20
the
is
negative, and I calculated that, that wasn't an issue, it's just that the way the way I picked it up there. Because I was picking this as a negative, I brought this over there.
Okay, yeah, thank you.
What happens is
That area.
Yes,
No, it would be the
yeah,
area
that's a Z-score.
zero and because it says at or below.
0.
Okay.
Go ahead, you guys think yeah. It's just, the mean is, you could think of the mean as 0, but it's just asking you, it's already giving you standard deviation. It's saying standard deviations above the mean. And you want to know how much data is below if there's standard deviations above it. Exactly.
This is exercise at the end of
Oh, it's this.
On page 206, on page 206, David, page 206 in the book. That's all I
No,
can tell you.
because I only had like the first two chapters. Zero is
Okay, if you don't have page 206, you don't have this. But you can look at it.
at home.
Okay, what's that?
What's your comment? Yeah, it's like, but I'm just not sure, because it says it's then the note table in appendix A to find.
The right,
the
right.
That will be anything in front of 1.6.
So right, so anything to the left of it would have to be subtracted. That's the part that's gonna be.
Yeah.
Because it's the right, I'm thinking it,
You know, so
we would look at it
Which one
here,
is it?
and if we looked at it here.
Number 7? Use the sterno normal table.
So if it was
Appendix
negative.
A, the first A.
It would be.
Appendix is in the back.
That's the mean. So is it, so is it?
So you look at 1.64, and that will be at,
So
all the numbers below that would be
So it
at,
says
or
at the
below that would be
1.64 standard deviation to the right of the means.
That would be that Z-score.
Use the normal table and find the area. Here's the area.
Yeah, whatever the
Number,
1.64.
whatever the relation next to it is.
Because then will we subtract that?
1.6.
So you see the one below is
All the number below it would be.
at or is the difference?
0.949, point.
So if you add the 4 together, it's already on the line.
You see what I'm saying? So it's like,
And then add or below
Z-score
0.2
represents the
standard
number
deviation to the
at
right of the
or
means.
below.
To the right, what is to the right and to the left? Wait,
So what's this number? That's the
Right. See, this is the mean, you go to the right, so that's a positive sign. Positive Z-score. If you go to the left, that's a negative.
saying to the left, to the right, right this way. The 1.64. To the right, towards the front. Then start the front. 4 braces to the right, the mean to the right.
So,
194.
1 minus 9.
Oh, but you're saying to go one more over?
It says to the right.
No. This is Z square. Right, 98. That's what you got. But this is Z score of 2.15. If 2.33. If it's on this side, 2.33. But you're not on this side. Yeah. But this number is also equal to 99.1. Okay? So this remainder is 0.09. But you're not on this side, you're on the left side. So you're 2.33 here.
And that's just the one I was telling you, consumer
Okay?
behavior.
So this number is still 0.
It was like, yeah, like it's like 8 o'clock, he's like, okay, where's the money? Yeah, he's really good. He's experienced, but he's not all about, more about you retain
Where are we
and not
now?
take this test. Like, we had no quiz.
They're on A.
It's just the kids study.
That's what the top means. That's what the Z-score means as that standard deviation. Well, that question.
What do you think? Great. You got them all right though.
The question is asking
Now,
what's
the
in
C,
between.
the one, the C kind of threw me off with that 67, like, what do you think?
So you look
You got your A.
at 0.67, right?
Yeah, we did that.
So it says.
7. So alright, well, so what's below 0.67? What percentage is below that? Okay. Alright, is that your final answer? No, you need to subtract out that little tail on
So
the
now
right,
let's go
right?
back to here.
No, you need to figure out what's below negative 2.15.
So the first one is 1.64.
Well, you need to figure out what's here. That's the key.
This is 1.64.
But since this is a negative, it's gonna be slightly tricky. That's the only thing. You can't just look up 0.215. You need to look up the positive.
Then subtract,
Second one is large.
and then use that number to subtract from whatever, 0.67.
Like you got this, like, did you get this one? Yeah. You got this one? What's the answer here? The Z-score was given, negative 2.33. Yeah, like what percentage is in here? What'd you get?
Where'd you get a negative?
That's
That's how we get these numbers.
It says on the left.
9.09%.
Good. All right, should we do 7 together?
Yes.
And then, let's do 7, and then we'll break again, and you'll do 8. Let's do it that way?
Yeah.
Yes, please.
All right, so, use the standard normal table to find the area at or below 1.64 standard deviations to the right of the mean. So for each of these, I would draw a picture and think it through. It's the only really hard and fast rule for figuring this out. Draw a picture, think it through. So 1.64 standard deviations to the right of the mean. So the mean is here, has a z-score of 0. Alright, this is 1.64 standard deviations to the right, so you know it's positive. And it's asking you everything at or below that point. So this one's pretty easy. All you need to do is look up 1.64 on the z-table, and it gives you the correct answer. What do you get?
94.95.
94.95%.
Yes.
I'm happy with that. Does that make sense? Okay, good. Let's do B. At or below a point 2.33 standard deviations to the left of the mean. And so the mean is here, it's 0. This is 2.33 to the left, means it's a negative. If this were a tree, it would be a really short tree. We need the area below that. Okay, so this is a little tricky because we don't have negatives on our z-score. So how do we figure this one out? Do the positive and do a 1 minus deal. Yeah. Alright, so
you get the 98.96, and then you do the minus, right?
okay, and what do you get?
98.97, right? Minus 1? Oh, no.
What's your answer?
9%.
0.99.
Right.
0.99%. Correct.
So very, very close to 1%.
1%.
Okay. So you were saying you got the point. What'd you get initially? What was the first thing you said when you look up positive 2.33?
Well, that's
9898. Okay. So you're gonna take. You could take 1 minus 0.9898.
Oh, no, 9901, that's fine. It's number 3, right?
9901. Yeah.
That's what I said.
1 minus 0.9901 is going to give you a 0.99%.
But if
Okay, good. So to get this area below the negative z-score, we need to do a 1 minus deal. If we wanted to, let's do that the long way though. We just did that just kind of verbally. Let's draw a picture for that particular point. Let's look up 2.33 positive.
Right.
Alright, the area below that is, I'm sorry, one more time?
99.01.
99.01%. Okay, and we want to know what is right here. Well, 100 is the total, 99.01 is here, so that leaves 0.99%. Now guess what, if we have the mere opposite of that, that's going to be the same thing. The reason I wanted to slow down and do this is because we have to do a calculation like this for the next one, but it seems more complicated. But it's not. It's just this same thing. So, let's do problem part C. An interval starting 2.1 standard deviations to the left of the mean and ending 0.6 standard deviations to the right of the mean. So 2.15 to the left and ending 0.67 to the right.
So that one is 98.47 to the left, 2.5.
So 2 steps to this one.
Like you got a first.
First, what's the area below 0.67? The whole thing,
77.94.
74.86%,
Yeah.
is the whole thing. Is that our answer?
Yes.
Wait, so is that our final answer?
No, because we gotta do 8.6.
We got to subtract off this little guy here.
Yeah. that is.
How are we going to find this little guy here?
With 100, percentage.
2.15.
We're going to look up positive 2.15, 1 minus that. And what do we get for this little guy here? 1.58%?
Wait, we need to see
No,
that.
0.015.
How much?
Okay, I gotta do
Is that right?
No, it's 1.5.
Wait, how do they do
1.58%?
It's 98.42, and then what they do?
1 minus that.
Right.
But instead of jumping right to the 1 minus, I would draw a picture like we did here. That's I think the first step. Draw a picture and say, well, this must be this. Okay, so 74.86 minus 1.58 is going to give us a final answer of what? 0.28? Yeah? You feeling that? Right.
73.
Let's finish up these last three. What do you say? These last three for 8. I'll get the screen back up if we need it. All right.
The interval between.
My son, this is not mine. That's my son's.
See her,
They did?
now I can know how to work it out. Yeah.
And you've got the negative, you know you have the negatives there?
Yeah.
You could just go straight to the negatives. All right, what do you think?
So I did it, but it's
Where we did that would be
Go out beyond the
0.67 and negative 2.65.
so it says out.
You want to do your
Like, once you get that number,
Today was such a crazy day.
one of us has to write and one of us has to talk. Totally confused.
Those are Z
Right,
scores.
so the first one.
no, but I
So
mean,
here you go.
I got that.
Yeah, okay.
But then we just subtract it from the
Direct
1.85.
We took 74.86 minus
So that was just
1.58.
deviation of
Right here.
So
1.9.
that should be clear because you know
So the right is
this 74.86 includes this whole thing, and we want to subtract off this little tail to give us just the in-between.
If you have.
Is that, you're clear there, right? The little tricky part is how do we get this 1.58?
Right, but we subtracted it.
if you don't, you just.
Well, how we got the 1.58 is we looked at positive 2.15
Right,
and then did a 1 minus.
97.50.
okay. So no, I was getting lost because I'm thinking that you take that and then you get another, like over the table.
In an
But you
interval
just use
starting
that
at
from
point
when it's
six.
set.
So you have the
I'm
interval
not sure what
starting
you're
at
talking
point
about.
six.
But
No, I got
To
it,
the right of
because
the
we
mean,
got the Z score,
0.6,
right?
right of the mean, and ending
Which
with
is the
1.6
seven.
standard deviation
I
to
think
the
it's
right
just,
of the mean. Wait a
you
minute.
need to do 1 step at a time.
From
So,
the beginning.
yeah, so
Starting at
the,
1.6.
Right.
Interval starting
Got
at
that.
1.6 standard deviation
That was
to
the-
the right of the means, and
So it would be
ending
similar
at
to
1.6. So is this, and
So I
then
think
ends
1.6
here
was like
at 1.6.
Right.
Standard deviation to the right of the means. So it starts there and ends this, we
Then
gotta
you
find out the
subtract
number
it
between
from
those.
the
So
one.
you have to do 1.6
The next, I think.
first, because we have this number.
Either way, I think either way.
Because it's negative, the 2.1.
It was just 1.6.
Because if you do minus the positive of this, and then we get it right.
So it's 9.452.
So, okay, wait, what
Then
is the
the
problem?
point
It
six
says an ending.
is
Okay, so to the right of
Sort
one,
of, so
point
And
still
ending
have
at
to
1.7.
seven.
to the right. So they're both to the right.
So because this is not a negative, you don't have to worry about it. Now you're gonna minus those two out.
But I see what you're saying, so the negative is minus the negative from.
But I'm not sure.
So let's try. So we'll do 6 from the positives.
So the second, the third one.
To the positive.
And the interval starting at 1.2 standard deviation to the left, so now it's going to the left,
I'm sorry, late.
right?
Need help, sir.
Starting to the left is a 1.2 standard deviation to the left of the mean,
Which
and
one?
ending at
I think I did it right,
1.5.
but let's
So you're gonna start with 1.2,
B.
and then you're gonna end at 1.5.
So now we're gonna get the negative.
Right, you're gonna do the so this is negative 1.5 is point
Is it to the left or to the right for 1.6 on B?
668. And then what's the other one, 1.2? 1.2 is 0.1159.
On this side. And then you look at the whole mean.
Okay, no, because see, I was taking that 1.5
So then now
and
we
going
just
back to
subtract
that.
the 2.
Then the whole.
I was adding another stuff.
So what I look at.
No, because I already did it. I gave you the negative, I gave you
I got
the, I'm looking at the table with the negative.
Oh, so the answer is 26, that's the answer?
To the right of the median, so you just do it. Boom, then you get the whole thing to the left. 72. Is the warning. And then same thing on this one, right? To the right.
The big one?
So when it says the left, so now if you look
To
at
the right of the mean.
the left
So
is
same thing,
negative.
they got 94.52.
The number is
And then they just
right?
try to see distance, whatever.
That is point.
And the other two is to the
So
left.
if you look at it, if you do it that way, right?
Same thing in table, but then you should
So 48, 4 point.
over here.
Yeah, it's 0.4.
Little thing left out.
Right.
Yeah.
No, it's actually, no, it's not.
I got 0.04, but if you make this into a decimal, it's.
Of the mean.
I did the big one.
The mean is the middle.
I did 1.29, I did the number, 1.29.
But look at the first one. This is right of me, so 196.
You look at 196, see the curve?
The way you said it, it was like
196.
the
It starts,
You want to find this
it
area.
starts at 1.2 and it ends at 1.5.
To the right of the mean.
So this is.
Look at the word right. To the right of the mean, so you check the graph. Look at the mean, and then you go the right here. The whole thing to the left, and the whole, what is, no, the trace below that trace.
They had it so hard.
Not in the same big one. Yeah, no, I mean, it makes sense, like, it's just a word.
All right, do you want to just do it?
Do you have a question?
They're both, no, they're both to the right. They're both to the right.
So the question asks,
So you have to try to higher number.
the interval starts at 1.2, right? And then it ends at 1.5. I would put the 1.2 here and 1.5, or does it? Shouldn't I write 1.2
Yeah.
and then the 1.5?
1.2 goes here.
And you got 12?
Negative 1.5 goes here, negative 1.2.
So it's right that way.
So you go this way, negative.
Yeah, so it
It
says,
doesn't say negative here.
it says to, it's to the left.
It's to the left, that's what I'm saying, that's why, because it increases, because 0 is here, so the bigger number, so that's the. And then,
No,
because
because it's the medium. The medium is here. Medium. All right, let's do
All right, we ready to do this?
So it goes this way.
Let's get rid of this. Or no, actually we need this. Alright. Use the standard normal table to find the area out beyond 1.6 standard deviations to the right of the mean. I like the way that's worded right. Out beyond. So 1.96 standard deviations to the right, and it wants to know everything out beyond. I didn't tell you, this technically goes on forever. Alright, the probability of a super, super tall tree is very low, but it exists. You can go on forever, and you can say there's a tiny, tiny % chance that a tree would be that big. In any case, how do we calculate that?
Look it up.
Yes, you look up 1.96, what do you see?
97.5.
Alright, so what is the percentage out beyond? So what's below 1.96?
So below it is,
Below it is 90, you said 97.5, right?
right,
Okay, so what's above?
96.
97.5 is below.
Right.
What's above?
2.5.
The difference of the total to 100.
2.5.
97 below, 2.5 above.
Right.
So the answer is 2.5 is out beyond. 97 below, 2.5 above. It's good we have a nice clean example like that, right? These other ones are the same logic, it's just they're not as easy to think about because they're not as clean.
Got it. How much
So 2.5.
In intervals starting 0.6 standard deviations to the right of the mean and ending 1.6 standard deviations to the right of the mean. So 0.6 standard deviations to the right and ending 1.6 standard deviations to the right.
Right.
So we need to look up both of these. This one's not too bad because we look up this one, we find the area below, and then all we need to do is subtract off this part, which we can calculate if we just look up 0.6. So let's look up 1.6. What's the area below that?
94.52.
94.52. Fantastic. Is that our final answer?
Yes.
Agreed.
Not quite.
Let's vote.
97.5.
We need to subtract off this guy right here. Right?
And that's the 72.
72?
72.57.
Right. Nice. Minus 72.57 gives us
2185.
21.85%. Fantastic.
95.
9.5.
9.5. Right on.
21.95.
Okay.
Last one. The intervals
Same thing.
starting 1.2 standard deviation to the left and ending 1.5 standard deviations to the left.
I did the same
Right.
thing with that one.
So to the left means negative.
Yes.
Correct.
Alright, below this the mean. Alright, so this one's a little complicated because we've got two negatives. So you just want to give me the answer?
I did put it.
You want the final answer?
Final answer.
4.83.
4.83. Do we all like 4.83%? Yeah?
Yeah.
Alright, so a number of ways you could solve this. Somebody actually told me last night, he just said, well, it's the same on the positive side, so I just looked up 1.2 to 1.5, and then I didn't have to do any 1 minus or any subtraction. You see what I'm saying? He said, let me just calculate 1.5 to 1.2 positive, and I got 4.8. If you didn't think about that, you could say, all right, well, what's below 1.12? Well, I need a positive 1.12, and then I need to subtract off, and to do a 1 minus deal, and then I get that tail, and then I need to do the same thing with the 1.5.
Right.
Any questions there?
That's another way to solve it and just beat
Good
the
work.
long way.
Excellent job. Look forward to seeing you next week.
Yay.
Let me know if you have any questions at all. So you know what to do. You know, you do the sample homework problems, there's suggested homework problems. You do the Excel exercises, you take the quiz. If you have trouble getting the textbook and you need to wait a week on the quiz or the Excel exercises, that's fine. But it would be better if you got the textbook and started working on this right away, because next week we get into some new stuff already. Alright, see you next week.